Hey everyone, and welcome back to my channel. Have you ever wished that your AI model could provide you with answers that are not just only accurate, but perfectly fits your need? Well, in the world of LangChain, that's not just a wish, it's a reality. Today we will dive into three powerful tools in the LangChain Arsenal: Response Schema, RouterChain, and TransformChain. This incredible tool will give you power over how the AI model interacts with you, ensuring you get the information you want in the format you need it. We will start by diving into Response Schema, which acts as a blueprint for the AI's responses. And then we will tackle on the RouterChain, which help your AI model choose intelligently the best way to respond to your request. And finally, we will unleash the magic of TransformChain, which will allow you to enhance and refine those responses to perfection. Get ready to level up your LangChain skills and build AI applications that truly understand you and caters for your need. So, let's dive into the code and start chaining those responses. Alright, let's start with the response schema. In the AI world, it's not just about getting answers. It's about getting the right answers in the format that's useful to you. And that's where LangChain response schema comes in. Think of the response schema as a blueprint for your AI's output. It tells the model exactly what kind of information you want and how you want it structured. This is very helpful when you want to extract specific data point from a text, and not just a general response. But why use them? They help ensure consistency in your AI output, making it easier to process and use that information down the stream. They also give you fine-grained control over what type of data you get back. Now we will see this in action. We'll start with a basic example of LangChain chain to highlight the unformatted output. Then we will add the response schema to bring order in the chaos. So let's turn to Jupyter Notebook and start writing our code. Alright, let's create the basic chain. Okay? To create the basic chain, we need three libraries. We need LangChain, openai, and python-env. I have already installed them. So the next step is to load the openai API key. And to load the openai API key, we need access to the OS, to the file server. So we'll say here import OS, and then import openai, and then from .env import load and find. Next, we are going to say load.env find.env and override is equal to true. Okay. After that, we will say os.environ.get open AI underscore API underscore key. And we are going to print a message to the user: open AI API key loaded os.environ.get open AI underscore API underscore key, and the condition is not none. Let's run the code. And OpenAI API key loaded, it is true, which means that the OpenAI API key loaded successfully. I have already created before a tutorial about the LangChain chain. I'm going to leave a link for it in the description of this tutorial for your reference. So please make sure to check that tutorial as well to gain more knowledge about LangChain chain. Now let's start building our basic chain. To create the basic chain, we have to import some important libraries. So let me scroll up a little bit here. Sorry, till here, okay. Let's now write the code. First, we have to import from LangChain prompts import chat prompt template. We are going to use this for creating prompts for the large language model. Then from LangChain .chat_models, we are going to import chat openai. We are importing chat openai for using the openai chat model. Next, from LangChain.chains, we are going to import the LLM chain for creating a simple chain. Alright? Next, we are going to define our template for the prompt. I'm gonna call this template is equal multi-line string. We are going to define here a template that will extract title, sentiment, lead actor, genre, and budget from a movie review. Alright, I'm gonna show you how. So we'll see here, interpret the text and evaluate the text. Okay, title, it's title of the movie. Sentiment, overall sentiment. We're going to specify it as well, positive, negative, mixed. Lead underscore actor, which is name of the lead actor or actress. Genre, main genre of the movie. Okay, and I'm going to give it an example. Sci-fi, comedy, drama, and budget, which is going to be the budget of the movie. Okay, and I'm going to give him the LLM some instruction as well. So we'll say here is how we want the output to be structured. Okay, format the output as JSON with the following keys: title, sentiment, lead underscore actor, genre, price. Okay, and finally I'm going to tell this is where the input will go. Text input. Alright, so this is our template that we are going to use for our prompt. Okay, now we need to initialize the OpenAI language model, and to do that we have to do the following. Let me scroll up a little bit. Okay, so we'll say here LLM is equal to chat OpenAI. After that, we have to create our prompt template based on our defined template above. So we'll say here prompt underscore template is equal to chat prompt template dot from and template here, and for the template is equal to template. Okay, next we have to create now the chain that will combine the large language model and the prompt template, and we are going to call it chain is equal to LLM chain. We already imported this above, so we'll say LLM is equal to LLM, and then for prompt is equal to prompt underscore template. Okay, now we can run this chain and we can input the text. Okay, the text will be a movie review. So here we'll say chain dot invoke input is equal double quote, and I have already prepared a movie review. I'm gonna copy it and paste it just to save time. So if we did the movie Everything Everywhere All at Once was a mind-blowing masterpiece, and it includes the lead actor name and the price and the genre of the movie. Okay, so now we want to run the chain and check what is the output. All right, so let's run our code cell, and I get an error here because of a spelling mistake. It is template with capital T, so here it's T. Let's run the code cell again. It's running and we get the output. This is the input, the movie Everything Everywhere. Okay, this is our input, And if we go down here, the title is extracted, the sentiment is positive, the lead actor is Michael, and genre sci-fi, and price 5.12. So our chain works perfectly. And now is the question, what might be the issue if you want to save this information to a database? Or what might be the issue if you want to continue to work with this kind of information? The issue is that we have got a string because a large language model gets tokens or text as input and provide tokens or text as output. So this is not a dictionary and we cannot save that string to a database. So we need some kind of transformation, and we can do this with the response schema and output parser, which we are going to see now. To create our response schema, we have to import the response schema and the structure output parser classes from the LangChain.output parser modules. So we'll say here from LangChain.output parser import response schema and structure output parser. We need these classes to define the expected output format and parse the output from the language model. Alright? Next, we are going to define a list of response schema objects which represent the expected output format. Alright? So we'll say response underscore schemas is equal to, and the first response schema that we are going to define is for the title. So we'll say here response schema name is equal to title, and for description is equal to title of the movie, okay, of the movie review, okay. Next, we are going to define the second response schema, which is going to be for the sentiment. So we'll say name equal sentiment, and description is equal to overall sentiment, positive, negative, or mixed, okay. The next response schema is going to be name equal lead underscore actor, and description is going to be equal name of the lead actor slash actress. Alright, then response schema name is equal to genre, description is equal to main genre of the movie. Alright, example sci-fi, comedy, drama. And the final response schema that we are going to define is for the price, and here we have to add one more information for this schema. So we'll say here price description is equal to it's the cinema price, sorry, ticket price, okay. Use none if it is not provided. Alright, the additional information here is the type, because price is not a string, it's a float. So we are going to say here type is equal to float. Alright, and we pass it as a string, okay. Now let's print the response schemas for debugging purposes. So we'll say here print response schemas, and as we can see, this is all the response schemas that we defined above. Alright, now in this next step we have to create the structured output parser object from the list of these response schema objects, okay. This parser will be used to parse the output from the language model into a structured format, because we are going to receive the output from the large language model unstructured. So we need to parse it. So we are going to define here now our parser. So we'll say parser is equal to structured output parser dot from response schemas, which we define above, okay, response schemas. All right, next we are going to get the format instruction from the parser. All right, so we'll say here format
underscore instructions is equal to parser dot get underscore format instruction. All right. This instruction will be used to format the output from the language model. All right. Again, for debugging purposes, let's print the format instruction. So we'll say here print format instructions. And this is the format that we want. All right. The title is a string, the sentiment is a string, and price is a float. All right. And this is the JSON format that we are looking for. All right. Now we have to create a prompt template for the large language model. And to do that, we have to import a chat prompt template and system message prompt template classes from the LangChain prompts module. Okay. So we will say LangChain dot prompts import chat prompt template and system message template. So we need these classes to create a prompt for the language model. All right. Next, we are going to create a chat prompt template object with a single system message prompt. Okay. This prompt will be used to ask the language model to analyze the input text and return the sentiment, movie title, price, and so on. Okay. So here we'll say prompt is equal to chat prompt template messages is equal, we'll say here system messages prompt template dot from template, and here we are going to pass our prompt. So we'll say analyze the following movie review and here the input that this prompt will receive /n/n. Okay. Also just return the JSON. We just want the JSON format. Do not add anything. Okay. No interpretation. Okay. And here also we are going to pass the format instruction. Format underscore instructions. Okay. So these format instructions are from the parser. All right. Next, we are going to define the input variable for the prompt. Input underscore variable is equal to input. Okay. This is the input text that will be analyzed by the language model. Okay. After that, we are going to define a partial variable. So we'll say here partial underscore variables is equal to format underscore instructions, format underscore instruction. Okay. So here we are passing the format instructions as a partial variable to the prompt. Okay. Let's run the code and make sure we don't have any error. And it's working. All right, now let's create the input string. Okay, this will be the text that we are going to pass to the large language model to be analyzed. Okay, so we'll say here input is equal to prompt dot format a prompt. Okay, and for input I have already, as I said before, prepared the movie review. So this is the movie review. Okay, and before here we continue, I noticed that I made a mistake. Here there's no colon. All right, just make sure to delete it from here. Now let's pass the input to the large language model and get the output. So we'll say here output is equal to LLM input.to underscore messages. Okay, so this is where we actually call the language model to analyze the input text. Okay, and now let me print the output. We are going to print now the raw output from the language model. Before that, let me run this code cell again and this one. So it's running now. And we get the raw output from the language model. As you can see, it's not user-friendly. We cannot work with it. It's just a string, okay? So now we are going to parse the output using the structure output parser, okay? So we'll say JSON underscore output is equal to parser dot parse. And here we are going to pass the output dot content. Okay, so we are taking the raw output from the language model and parsing it into structured format using the parser we define above. And after that, I'm going to print JSON underscore output. Let's run the code, and we get the JSON format that we actually need and we define above. Okay, and there you have it. We have successfully transformed the original movie review into this clean structured JSON format. As you can see, our response schema acted as a blueprint. It is guiding the AI to extract the exact pieces of information that we wanted. All right, the movie title, sentiment, lead actor, genre, and even the ticket price. So this neatly organized format makes it much easier to work with the data. We could store it in a database, use it for further analysis, or even display it in a user-friendly, let's say, website or app. Okay? So response schemas gives you incredible power and flexibility to tailor AI outputs to your specific needs. Okay? So now imagine the possibilities when we combine this with other LangChain features like router chains and transform chains, which we will explore next. All right, so let's move on to the next section and continue learning about LangChain advanced tools.
Alright everyone, now we will take our LangChain skills to the next level. So far we have given our AI model a single prompt to work with. But what if you want our chatbot to be more adaptable and intelligent? What if you wanted to handle different type of questions or tasks? That's where RouterChain comes in. They are like the traffic director or controller of the LangChain universe, directing different input to the most suitable destination. In this section, we are going to build a RouterChain that will dynamically select the right chain for the job. So, let's dive into the code and see how to create this intelligent routing mechanism.
Alright everyone, now we are going to create a multi-prompt chain using the LLM router chain in LangChain. So we are going to define 3 different prompt templates: positive, neutral, and negative. And we are going to use them to create individual chain. The router chain will analyze the input and select the most appropriate chain to be used based on the sentiment of the input. This will allow for more accurate and tailored responses from the model. Okay? So to do that, as usual, we have to import the necessary classes and libraries. Alright, so we'll start from LangChain .chains.router import multi-prompt chain. Okay? This will be used for creating and managing the chains. Alright? Next, from LangChain .chains.llm import llm chain. Okay, this we are going to use it to create the individual chains, okay, which are positive chain, neutral, and negative. Okay, next from LangChain .prompts import prompt template. So this we are going to use it to create our prompts. All right. Then from LangChain .chains.router.llm underscore router, we are going to import LLM router chain and router output parser. Okay, so we are going to use these classes for routing and parsing the output of the large language model. And here finally from LangChain .chains multi-prompt prompt, this one, okay, module, we are going to import multi prompt router template. Okay, so here we are importing a predefined router template which we are going to use. All right, I'm going to show you how. So the first step is to define 3 templates: positive, neutral, negative. All right, so we'll say here positive underscore template is equal to you are an AI that focuses on the positive side of things. Okay, whenever you analyze a text, you look for the positive aspects and highlight them. Okay, here is the text. Okay, and here the input. The input placeholder will be replaced by the user text. Okay, and to save time, I have already prepared the neutral template and the negative template. So here I'm going to paste the neutral template and negative template. You are an AI that has a neutral perspective. You just provide a balanced analysis of the text, not favoring any positive or negative aspect. Here's the text. And also here's the negative template. You are an AI that's designed to find the negative aspect in a text. You analyze a text and show potential downside. Here's the text as well. Alright, in the next step, we are going to store the information about each prompt and each associated chain. By this mean, we are going to create now an object called prompt underscore infos is equal to an array of object. An object for each chain that we are going to create. So the first one, name, is going to be positive. Description, good for analyzing positive sentiment. All right, and the prompt underscore template, okay, is positive template. Let me scroll up just to make sure you can see it. All right, so this is the information for the first chain. It's name, description, and the prompt template. And we are going to do the same for the other two. So name is going to be neutral. Okay. Description, good for analyzing neutral sentiments. Okay. And the prompt underscore template is equal to neutral template. All right, and the third and final chain for the negative, name is negative and description, good for analyzing negative sentiments. Okay, and the prompt underscore template is negative template. All right, let's run our code and make sure everything is working fine. Yes, we get no errors. All right, now we are going to initialize a dictionary to hold the different chain. So we'll say here destination underscore chains is equal to an empty dictionary. All right, so here we have, to recap, we have the prompt for each chain, and here we have the chain information, and here's the destination chain, which is going to be a dictionary to hold all the chain. Let's run the code. Everything is working fine. All right, now we are going to create a chain for each prompt, and to do that, I'm going to create a for loop and loop over the prompt information. I'm going to extract the name, and which is going to be the name of the chain, and then it's a prompt template. All right, and then I'm going to create the prompt template object with the template and input variable, and after that I'm going to create a chain. So instead of creating the chains one by one, I'm going to create now a for loop to do that. All right, don't worry, I'm going to explain it. So here I'm going to say for p underscore infos in prompt infos. All right, I'm going to loop over this information, and then I'm going to say here name is equal p underscore info name. All right, and then prompt underscore template is going to be equal p underscore info prompt underscore template. All right, so we're extracting the name of the chain, and the next line I'm extracting the prompt template. Now I'm going to create a prompt template object Here there's no comma, sorry for that. So now I'm going to create a prompt template object with a template and input variable. So here we'll say prompt is equal to prompt template, all right? And the template is equal to prompt template, which we define here, okay? And the input underscore variables is going to be equal to input, all right? Okay. After that, I'm going to create a chain. So I'll say here chain is equal to LLM chain, and LLM is equal to LLM, comma, prompt is equal to prompt, okay? And finally here, the destination chain, which is the empty chain here, I'm going to add the name, which is going to be, for example, the first one, the positive, and its associated chain. So it's going to be the chain that I just created, all right? So this for loop, with this for loop, we are going to create three chains, all right? Let's run the code and make sure everything is working fine. And I get an error, p underscore info is not defined. Yeah, here I forgot an s, all right? An s here, spelling mistake, sorry for that. Let's run the code cell again. And our chain are created by now. Next, let's create now a list called destinations. This list will contain string representation of the possible destination to our router chain, okay? So each destination will be a combination of the chain name and its description. So we'll say here destinations is equal to f string, and here we are going to define p name, all right? And this is the name of the chain, and its destination is going to be also here p, and description. So the name and the description for each chain. But where to get this information from? We'll say here for p and prompt underscore info, all right? So here we are creating, as I said before, a list called destination that contains the string representing the possible destination for our router chain. And each destination will have a name and its description, okay? Let's print the destination for debugging purposes. So we'll say here print destinations, all right? So as you can see, we have positive, good for analyzing positive sentiment, neutral, good for analyzing neutral sentiment, and so on, all right? Now we are going to join the elements of the destinations list into a single string, separated by a new line character, okay? So this string will be used to format the template for the router chain, all right? So here we'll say destination underscore string is equal to new line dot join and destinations, okay? All right, let's print the destination string so that you understand what we are doing, all right? Let's run the code. And as you can see, we join the element of the destinations into a single string separated by a new line, all right? Now we are going to create the router template. So here we'll say router underscore template is equal to multi prompt router template dot format destinations is equal to destination underscore string, not underscore string, all right? So here we created a template for the router chain prompt. The multi-prompt router template, as I said before, is a predefined template in LangChain that help structure the prompt of the router, okay? And the dot format destination equal destination underscore string part, it fills the template with the list of the destination chains and their descriptions that we created earlier. This gives the router the information it needs to decide which chain to use, all right? So let's run the code. It's working. Next, now let's define the router prompt. So we'll say here router underscore prompt is equal to prompt template. For template, we are going to say router template, okay? and for input underscore variables is equal to input, alright, and then for output parser is going to equal router output parser. Okay, so we are going to use this to parse the router's output to determine the appropriate chain. So here we created the prompt template object for the router. Okay, so this object will be used to structure the prompt that we will give the language model. Alright, and the router output parser, this sets up a special parser, okay, so that will help interrupt the output of the language model when it's acting as the router. It will try to understand which chain the model is recommending based on the user input. And let's run the code. It's working fine. Let me scroll. Alright, now we will create the router chain. So we'll say here router underscore chain is equal to LLM router chain dot from underscore LLM, and here we are going to pass what the prompt, no, not chain, the router prompt, sorry, the router prompt. Okay, let's run the code, make sure it's working. It's working fine. So we created the actual router chain here, and it uses the language model and the router prompt that we just created. Okay, the LLM router chain dot from underscore LLM, it will automatically handles the logic of passing the user input to the router prompt, getting the response and parsing that response to determine which chain to use. And now let's create the main chain for our application, which is the multi-prompt chain. So we'll say here chain is equal to multi-prompt chain. Okay, so this will be the main chain for our application, which is responsible for orchestrating the entire process. So think of it as the manager of your AI system. It's a special kind of a chain called the multi-prompt chain, because it can use multiple different prompts and chain to respond to various types of input. Okay, so the first one is the router. We are going to define the router here. Router underscore chain is equal to router underscore chain, which we created above. Okay, and then destination chain is equal to destination chain that we created. Okay, and the default chain is going to be destination chains, which one? The neutral. Okay, so the default chain will be the neutral. Okay, and I'm going to set the verbose is equal to true. It's optional but helpful for debugging. When we set it to true, LangChain will print out intermediate step in the LangChain in the chain's execution. It will show how it's making decision and which chains are being used. Alright, let's run the code and make sure we don't have any error. And now we can test the chain with an input. So we'll say here chain.invoke, and here I have already prepared an input. The new iPhone 15 Pro Max boasts incredible camera capabilities, but the price tag of $1,599 is a bit steepy for many customers. Now we will run the code and check every step executed in the chain. Alright, so let me scroll up a little bit, and now I will run the code. It's entering the multi-prompt chain and I get an error. Let's check why we get an error. Yeah, here I have a spelling mistake. I missed an I. So let's run the code cell again from the beginning. Alright, just to make sure. Yeah, so let's run this. And this one, this, and this. Okay. It's entering a new multi-prompt chain, and it chooses the positive chain. So the initial message from LangChain itself is indicates that chain.invoke call has been initiated and the multi-prompt chain is invoked. Okay, and it started to work. And based on the input text, the iPhone 15 review, the router has determined that the positive sentiment chain is the most appropriate chain to use. Okay, the input text is then passed as a dictionary to the positive chain ready for processing. All right, And finished chain here, this message indicates that the selected chain, in this case the positive chain, has finished processing the input text. And as you can see, the final output is a dictionary in JSON format. Input, this is simply the original input text we provided to the chain. And text is the response generated by the positive chain. And as you can see, it focuses on the positive aspect of the iPhone 15 Pro Max, highlighting the amazing camera capabilities and the innovation involved. So here, the RouterChain successfully determines that the input has a positive sentiment, even though it contains some negative element, the high price, alright? The positive chain response is tailored to the task, emphasizing only the positive aspect of the product, okay? And finally, there you have it, a working demonstration of how LangChain's router chains can intelligently direct your input to the right model for the job. These powerful features allow us to create more versatile and responsive AI application. In the next part of this tutorial, we will make our customization even further by exploring how TransformChain can refine and modify our model's response.
Alright everyone, now that our chatbot can handle multiple tasks, let's focus on making its responses even better. Sometimes the output from the large language model is not exactly what we need. It might be too wordy, poorly formatted, or even in a different language. That's where TransformChains comes in. They allow us to enhance and refine the AI response to make it useful and presentable. Think of them as the final touches that make your chatbot shines. In this part of the tutorial, we are going to create a TransformChain that will clean up text, convert it into a different format, and even translate it into a different language. This will give you a powerful tool that will help you to tailor your AI output to your specific needs. So let's turn to Jupyter Notebook and start writing our code.
We'll start first with a simple transform chain. Alright, so we'll say from LangChain dot chains import transform chain, and then from LangChain dot LLMs import openai. Okay. Next, we are going to define a transform underscore function that we are going to use when we define the TransformChain instance. This function will take one argument, which is the input. Text is equal to inputs text. Then we have the transformed underscore text is equal to text dot upper. All right. This chain will convert the text to uppercase. Then we are going to return transformed underscore text, which is going to be the transformed text defined above. All right. Let's create an instance of our LLM. So we'll say LLM is equal to openai and temperature is equal to 0.9 for creativity. Now we will create an instance of the TransformChain. So we'll say transform, I'm gonna call it transform underscore chain is equal to TransformChain for input underscore variable is going to be equal to text. Output variable is going to be transformed underscore text, and the transform function is going to be the transform function we define above. Okay. Now we can test our chain by passing the input, but let's define an input text first. So here we'll say input underscore text is equal to hello world. Okay, this is an example of TransformChain. Okay, now result is equal to transform underscore chain, and we are going to pass the text input underscore text. All right, and I'm going to print the result at the end. It should print an uppercase letter of the input text. Let's run the code. And as you can see, this is the input and this is the output. This is just a simple transform change to show you how you can transform the output from the large language model. Now let's start working on an advanced transform chain. This advanced transform chain will first summarize the text using OpenAI. Then it will transform the text to uppercase letter and append its length. And finally, it will translate it into a different language. Alright, let's start writing the code so that you understand and see how it works. So we'll say from LangChain .chains import TransformChain. We want the sequential chain. We'll see why in a minute. And LLM chain. Alright, and then from LangChain .llms import openai. Then from LangChain .prompts import prompt template. Chain 1, say define a chain for summarizing the text using OpenAI. So we'll say here LLM is equal to OpenAI, temperature is equal to 0.9 again, and then summarize underscore prompt is equal to prompt template, input underscore variable is equal to text, and the template is equal to summarize the following text. After that, I'm going to define the summarize change. So we'll say here summarize underscore chain is equal to LLM chain. LLM is equal to LLM, and prompt is equal to summarize underscore prompt, and output underscore key is equal to summary. So the output from the first chain will be the summary. Okay, let me scroll up a little bit. Okay, now we will define chain number 2. Chain 2, define a chain for converting the summary to uppercase and appends its length. Okay, converting. All right, so we will define here a function transform underscore function. It will take inputs, one argument, and then we'll say summary is equal to inputs summary, and then transform underscore summary is equal to summary dot upper. Then we'll say summary underscore length is equal length of the summary dot split. Okay, this is the length of our summary, and this transform function will return a dictionary here, transformed underscore summary to transformed underscore summary here, and the summary underscore length will be the summary underscore length. So we'll say transform underscore chain is equal to transform chain. Input underscore variables is equal to summary. It will take the summary from the first chain, and then output underscore variables is equal to transformed underscore summary, comma, and the summary underscore length. All right, and the transform function is equal to transform function. Now let's define the search chain. So we'll say here chain 3, define a chain for translating the summary to another language using openai. So we'll say here translate underscore prompt. As usual, we have to define our prompt first using the prompt template. The input underscore variables is equal to transformed underscore summary. Okay, and the template is equal to translate the following text to French. Okay, and this is the input text. Now we will create the translate chain. So we'll say translate underscore chain is equal to LLM chain. LLM is equal to LLM prompt is equal to translate prompt. Okay, the one we just created, and the output underscore key is equal to translated underscore summary. All right, so now we have 3 separate chains. How to combine them? We have to use the sequential chain. If you guys want to know more information about sequential chain, I have created previous tutorial on my channel about sequential chain, how to create multi-agents, and so on. I'm going to leave a link for this tutorial in the link of in the description of this video, along with the playlist for the LangChain videos on my channel. All right. So here, let's say we are going to say combine the chains into a sequential chain. So I'm going to call it, let's say, advanced underscore chain is equal to sequential chain. This will take an input variable is text. All right, comma here, and the chains are as the following: summarize chain, transform chain, and the last one translate chain. Okay, and the output variables of this chain are the following. We're going to have the transformed underscore summary underscore lens, and translated underscore summary. All right, now let's test our transform chain. To test the transform chain, we have to define a text first. So here I will say input underscore text is equal to let's say LangChain provides a powerful framework for building language model chains. Okay, I'm going to run the chain now and store the output in a variable called result advanced chain, and here I'm going to pass the text input underscore text. All right, and finally I'm going to print the output, print result. All right, let's run the code, and I get an error here. I have a missing one validation error for TransformChain. So the error here, I forget here I missed an S. Also as well here in the transformed summary. Here also as well, transformed summary. And here we have TransformChain. And here as well, I have to copy this transformed summary to here. All right, let's run the code. And it's working, as you can see. It transformed it first to uppercase, and then it translated it as well.
And that's a wrap on our deep dive into response schema, RouterChain, and TransformChain in LangChain. By now, you should have a much deeper understanding on how to build more sophisticated and intelligent AI applications using LangChain. And remember, these advanced chaining techniques are incredibly powerful tools, that open up a world of possibility for your AI projects. If you enjoyed this tutorial and want to see more LangChain content, be sure to hit the like button, subscribe to my channel, and ring the notification bell so that you don't miss any of my upcoming videos. Thank you for joining me on this AI journey, and see you in the next video.